I'm doing 6.3 practice C number 13, which is to find the composite of f of x and g of x, to find f of g of x. So just to refresh your memory, I don't think anybody has any problem. If I was to find f of 7, that would be 2 times 7 squared minus x. Oh, nope. Minus 7, just substituting 7 in. If I wanted to find f of b, that would be 2 times b squared minus b. So simply evaluating the expression for what is inside the parentheses, for what is the argument. Inside the parentheses is called the argument. So what is the argument of the function? Well, I'm not being asked to find f of 7 or f of b. I'm being asked to find f of g of x. So I'm going to do the same thing. I'm going to go f of g of x is equal to 2 times, well, g of x is x to the negative 1/2 squared minus x to the negative 1/2. That's what I'm being asked to evaluate. Okay, so I can do that. This would be 2 times x to the negative 1, multiplying my two exponents here, minus x to the negative 1/2. So I'm going to write that a little bit differently. I'm going to write that 2 over x minus 1 over the square root of x. And if I want to combine that even a little bit more, I'm going to find myself a common denominator, as well as rationalize the denominator of my last term. And so I get 2 over x minus the square root of x over x. Sorry, I wrote 2 over 2 even though I meant 2 over, even though I said 2 over x. So my answer is 2 minus the square root of x divided by x. Now I need to specify what is the domain. So I'm going to go back to my original functions. And first I'm going to look at the inside function. I'm going to look at the inside function g of x. And the g of x, I'm going to rewrite it so that maybe even a little bit easier to see. G of x is 1 over the square root of x. And I can see, knowing that I can't have 0 as a denominator, and knowing that the domain of the square root of x is all non-negative numbers, I know that the domain of g of x is going to be not including 0, but anything up to infinity. So I can't have any negative numbers because they would make my radical here undefined, and it can't have 0 because that would also make the whole fraction there undefined. So that is domain of g of x. Now I'm going to look over at the domain of f of x. Well, I don't see any denominators at all, so no variables in any denominators because I don't have a denominator. And I don't see any radical signs, so I don't need to worry about that. So the domain of f of x is all real numbers, negative infinity to infinity. So far I have the domain, the most restrictive part. Well, I have to do the domain of g to find out what is a valid argument over here on my f of g of x. And then I need to define the domain of f of x, and if there were any exclusions there, I would have to set that number equal to g of x, but that's not the case because I have no exclusions for f of x. So I'm just going to look to make sure that my composite function doesn't have anything unusual in it, and it doesn't. I mean, it has a denominator, but so did my g of x. It has a radical sign, but so did my g of x. So the domain for this was my composite, and the domain is everything from 0 to infinity.